Even numbers. Numbers that can be divided into two equal groups. Even numbers. Numbers that can be divided into two equal groups. Even numbers.
We'll use this hundreds chart to show how different patterns are made when you multiply by different factors. First, let's talk about multiplying by 10. As you see on the hundreds chart, all the multiples of 10 end with a 0 in the ones place. And the tens place seems to be increasing by 1 each multiple, which makes total sense because you're just adding a tens rod to each prior multiple to get the next multiple. And the multiples of 10 make a vertical column. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now let's look at the multiples of 5. The multiples of 5 also line up in vertical columns. The multiples of 5 have a 5 in the ones place or a 0 in the ones place. And every other multiple of 5 is a multiple of 10. And skip counting by 5 sounds something like this. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. The multiples of 2 also line up in vertical columns, but in every other column. Skip counting the multiples of 2 would sound something like this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100. All the multiples of 2 have a 0, 2, 4, 6, or 8 in the ones place. The multiples of 2 can all be divided into 2 equal groups. That makes them all even numbers. So there's another pattern on a hundreds chart I'd like to show you. Odd and even numbers alternate. Odd, even, odd, even, odd, even, odd, even, forever and ever. The multiples of 3 make a different kind of pattern. The numbers don't line up in columns. They kind of make diagonal lines. And if you wanted to skip count the first 10 multiples of 3, it would sound like this. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. The multiples of 4 make an interesting pattern. They do make diagonal lines, or you could see them as kind of wavy lines on our hundreds chart. Or maybe you see them as skipping every other number in a vertical column. Skip counting the first 10 multiples of 4 sounds something like this. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Here are the multiples of 6 on the hundreds chart. If I skip count by 6, it sounds something like this. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Take a second for yourself and see what patterns you can find in this hundreds chart. What patterns do you see in the multiples of 7? How about the multiples of 8? Here's an interesting one, the multiples of 9. Another interesting thing to mention is that if you add two odd numbers, their sum will always be even. Here's why. Look at 3 plus 3. If you add these two numbers, each number has a pair. It can pair up or group up with another one to make a group of 2. If you can have all groups of 2, you have a multiple of 2, which makes it even. So 6 is even. It's a different story if you add an even and an odd. In this case, your answer will always be odd, because you'll always have one number left over with no pair. Now how about if you multiply two even numbers? Well, your answer, your product, will be even, because all you're talking about then is groups of 2. Even times even is just more groups of 2. However, if you multiply two odd numbers and you try to pair up each number, you'll always have one left over with no pair. So if you multiply an odd number by an odd number, your product will be odd. But what about if I multiply an odd number with an even number? Well, it will always be an even product, because if you multiply an even number, it has groups of 2. And all you're doing is making more and more groups of 2. There are many, many more patterns for you to discover. There are many in this video that we didn't even talk about. Keep your eyes open for number patterns. It will help you do math much more easily.
Even numbers. Numbers that can be divided into two equal groups. Even numbers. Numbers that can be divided into two equal groups. Even numbers.